Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long, information-packed episode organized by the hardworking folks at Redmond Magazine features the observations and insights of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, high-performance enterprise networking solutions provider Juniper Networks. It's their support that makes this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is AIOps and the network visibility imperative. And our main presenter is technologist, creator of compelling content, and senior resultant, Howard M. Cohen. Before we get started, though, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for some questions, so please feel free to type your questions into the Q&A box at any time. We'll do our best to get to all of them. Our sponsors provided some extra resources you won't want to miss. They're available now on your console. And as a small thank you to the first 200 attendees who stick with us to the end, we will be sending you a $5 certificate to Starbucks. It's a cup of joe to go with the info. Now I'd like to introduce our first speaker. In his 40-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about IT and the IT channel. He is a sought-after speaker, an insightful observer of the technology landscape, and one of our very favorite presenters. You're in for an awesome session. Take it away, Howard.
Thank you so much, John. You know, we're going to have to work on my intro. And I just realized it makes me sound like I'm old and can't hold down a job. But we'll see what happens. Hello, everybody. What can I tell you? Welcome to today's session on, what are we doing today, John? AIOps and the network visibility imperative. I'll stop kidding around. Okay. Those of you who have been with me before on any of these presentations know that I love to start each presentation with a word of the day. And today's word really relates strongly to the importance of AIOps and network visibility because they both really depend upon it. And it's a challenge. The word, of course, is speed. And when it comes to network monitoring and network management, there are three things that we're concerned about. And they're the same three things that we're concerned about when we're handling big data, which makes sense because what crosses the network? Big data, maybe small data sometimes, but the three things that we're concerned with are volume, velocity, and variety, the three V's. Just taking a quick look at each one individually. Let's start with volume. We're talking about a volume of traffic crossing the network. And in today's networks, especially with big data, with more and more devices and people and companies coming online, the amount of traffic crossing the network just continues to increase. But we're still expected to manage it as well as we ever did. Now, along with the traffic comes from users. There are more and more users getting on the network and doing more things, and quite frankly, doing more sophisticated things than they've ever done before. Those users turn to devices to connect them to the network. And of course, the users are not alone. A lot of devices are on the network all by themselves in the Internet of Things. So we have more things than we have people on the internet at this point, and they're distributed amongst more locations than they ever have been before. So we're tracking more locations. Now, all of this, from the perspective of those who are monitoring and managing the network, create more telemetry. There's more telemetry coming in from more places, more devices, more users, so forth and so on. And that means that we're generating more and bigger logs than we ever have before. Because every transaction that happens on the network is getting logged so that we can analyze it and figure out what happened when we need to. Logs are also tracking applications, and there are more and more applications coming online all the time. There are more and more sophisticated applications that do more. And of course, they use lots and lots of data that also needs to be tracked. So there is a there's a large volume of things that there are a large volume of, and it's getting bigger. It's just getting bigger. Next up, let's talk about velocity. Okay, velocity, how fast we can move all that data from place to place to place absolutely depends upon how much bandwidth we have. How much data can we squeeze through the pipe? Can we get broader pipes, bigger pipes? In some cases, we're using better and better compression to shrink down the size of the data that we're transmitting, but there's a limit to that, just like there's a limit to how small Ant-Man can get. There's a limit to how small your data can get. We're trying to improve upon the protocols that we use to transmit and receive data back and forth, and there's constant development going on in that, but we're always battling latency, things that slow down the data flow, things that get in the way of the data flow. We're trying our best in every way that we can to reduce latency. And finally, there is the issue of variety. We've got a lot of different data types. Applications are now sending all manner of data types, from simple text to telemetry to sound and video, and many, many more. So we have to figure out how to deal with each of those data types. We have more and more remote users in more and more locations than we've ever had before. Turns out that work from home stuck, and a lot of people love it, and a lot of managers love it. A lot of people who run companies love work from home because they're getting more productivity out of their people than they ever did before. Who knew? So we have all these people out there connecting in various different ways, and we have to be able not only to see each of them, but we also need to secure each of them. Along with that, we have more and more cloud services coming at us. Each of the hyperscalers keeps on introducing new services, so their service menus are getting up into the thousands of different services. Add to that all the hundreds of thousands, perhaps millions of cloud services that are commercially available around the world. Each of those generates plenty of traffic that needs to be tracked. When you talk cloud, you have to talk about hybrid cloud, adding complexity. So now you've got some public clouds and some private clouds, and you're tracking both. And there's a difference. There's a difference in protocols. There's a difference in idiosyncrasies, if you will, amongst them. And of course, as if that wasn't complex enough, we've introduced multi-cloud. So not only do we have one hyperscaler, we have 2 or 3. Not only do we have one cloud service, but we have 10 or 20, and they're similar, but they each have a different feature that we want. Now we can combine them, so we do combine them. Of course, on top of that, adding to the variety and volume of traffic moving around the network from cloud to cloud to cloud, more and more of us are developing our applications using microservices in containers. And that traffic is tremendous. So the responsibility for managing networks and securing networks becomes extremely challenging because there's so much to track. And of course, the real management challenge that creates the visibility imperative is the simple fact that none of us are the Flash. None of us are that fast. There's no way that we can keep up with the real-time logs that come rolling in all the time. By the time we find something out of sorts on a log, it may be days, weeks, who knows. So we can't keep up with the flow of data and protocols and other traffic running across our networks. At this point, I'll remind you all of what our good friend Peter Drucker told us. If you can't measure it, you can't manage it. So the fact that we can't see the or we can't keep up with the data means that we really can't measure it properly, accurately, or in a timely fashion, meaning we can't manage those networks. Now, this is aided, of course, by a corollary that's been introduced to us by another good friend, the Invisible Man, who says if you can't see it, you can't measure it. So if you can't see it, you can't measure it. If you can't measure it, you can't manage it. We're in a real challenge. And I think that challenge is best summed up in the wisdom of the Karate Kid, who says if a man can't see, he can't fight. And that goes for women too. If you can't see, you can't fight. And so we need to figure out, how do we capture all that detail? How do we keep track of everything that's going on in the network? Okay, let's start by looking at what has been up until now. Up until now, we've all worked in traditional network operations centers. Yours may not be this big, but it's probably configured in a similar way. There are some large screens up in front of you that are tracking the core data and the most important factors, and you can look up at them and see what's going on, and that's great. In addition to that, however, you have a group of monitors in front of you, and they're showing you more specific data that you're responsible for seeing, assessing, and acting upon. So what do you see? Well, you see all kinds of traces going past you. You see data rolling past you, and it's generally moving very fast. So fast that you may not have time to analyze what it means to you, and you may miss things. Things may just slide by the screen before you even catch them. If you look up at the big screens, you may miss something on the small screens. Also, you have logs flying past you in just data scrolling and scrolling and scrolling and scrolling. So how do you keep up with all of that? And the answer is, of course, you can't. You can't because we're not the Flash. None of us can move or perceive things that quickly. However, even though we're not the Flash, whoops, that was great. Sorry. Even though we're not the Flash, AIOps is the Flash. AIOps moves as fast as the Flash. It moves at the speed of thought. It's just incredibly fast. It can keep up with the data. It can keep up with the logs. It can keep up with the traces. It can keep up with all the telemetry. Not only that, it can do far more. Now, quickly, let's just jump in and define what we mean by AIOps. AIOps is simply artificial intelligence for information technology operations. If you operate a network in any capacity, this is technology that was built for you, applying artificial intelligence, machine learning, cognitive capabilities, all to the task of visually monitoring and functionally managing your network operations. So the big key value that we've been talking about is visibility. And indeed, with AIOps to help you, you can see every device, every user, every application that's running, every protocol that's in use, every data entity that's in use, and by whom and for what. And all of that can be tracked because artificial intelligence is on the job. Not only that, it can alert you when something isn't the way it's supposed to be. And so visibility is just one of the things that AIOps gives us. There is another, and that is observability. We can not only see these things, but we can actually see what they're doing and what's resulting from what they're doing. Now, from the perspective of a user, that becomes very important. Users' expectations have skyrocketed over the past few years. It used to be that you can tell them, okay, we know it's this and this device, and it's spewing out too many packets, and we've got to figure out why it's signaling like the way it is. And the user is sitting there thinking, I don't really care. Just fix it. Well, nowadays, that just fix it is the rule. They expect that you will fix it before they call you to tell you there's a problem. And you know that. I'm telling you something that you know. So you have all this telemetry coming in. With AIOps on the job, all of that telemetry is coming into your data platform. And your data platform performs all kinds of analyses. It does a root cause analysis, so you can trace back what happened, why it happened, where that was caused. You can also start to look at adjacent systems and why conditions in those adjacent systems may have contributed either to the problem itself or perhaps to the severity of the problem. So you're getting a lot of analysis there. And the last thing that the data platform is responsible for is identifying and formulating a solution. And it feeds that solution back so that you can take action immediately, so that you can fulfill your user's expectation and get them back to work instantly. So it's not dependent upon you and your imagination and your experience to come up with the solution. No, the data platform, using the observability furnished by the artificial intelligence and machine learning, that actually solves the problem and makes you a hero with your users. Of course, what presentation would be complete without a reference to the Gartner glossary? And in this case, I went to the Gartner glossary to hear what they have to say about AIOps. And Gartner says AIOps combines big data and machine learning to automate IT operations and processes, including event correlation, anomaly detection, and causality determination. Now, that's a fairly robust sentence. There's a lot in there. Let's unpack it just a little bit. I noticed that they don't mention artificial intelligence because it's already mentioned in the contraction, AIOps, and it's very good. Obviously, the big data is the data that refers to your network, every device that's on it, every data asset, every user, et cetera, et cetera, et cetera. In terms of automating IT operations processes, event correlation means this happened. Let's figure out what else was going on when this happened and how it may have caused this to happen. Anomaly detection. Something is not the way it's supposed to be. One of these things is not like the others. Okay, you want the technology to do that because it's all too easy for humans to miss it. Again, we're not the Flash. And once you've figured it out, yes, you want to certainly go and fix it, but you also want to know what caused it so that later on you can change that, fix that, so that the same problem doesn't happen again. So the components of AIOps begin with real-time performance monitoring. There are sensors and software throughout your network that are monitoring various different features of your network, including the traffic going through your copper, fiber, and wireless network segments. There is anomaly detection with root cause analysis, solution development, all faster and more accurate than is humanly possible. Meaning we don't just look and say, oh, there's a problem. We figure out what caused the problem. We develop a solution for that problem, and we do all of that faster, which means that we're catching issues that humans might miss that are buried. And again, we go back to the volume, the sheer volume of data. It is all too easy for a human being to simply miss an anomaly flying by in all that data. Now, we're detecting and observing these anomalies across a local area network, wide area network connections, cloud connections, and more, including monitoring of the routers, the switches, wireless, firewalls, software-defined wide area, and most recently, secure access. Wow, here it goes again. Secure access service secure access service edge, and more. I mean, there's a lot of technologies I'm not mentioning here, but you get the idea. We're not isolating ourselves to one segment of the network. We're responsible for the whole thing, for the data getting from wherever it started to wherever it's supposed to end up. Again, I'm going to emphasize the importance of the underlying problem. We can go chasing after the same problem again and again and again and again, and ultimately somebody's going to kind of look at us and say, well, what are you doing? You know, you're solving the same problem. That's the definition of insanity, doing the same thing over and over again and expecting a different outcome. So we go looking for the underlying problem. We perform much deeper analysis so that we can understand what caused this problem, fix it, and not have to deal with this problem again. And again, resolving immediately the problem that existed, leveraging automation to do it, and thereby accelerating the mean time to resolution. When you've accelerated the mean time to resolution, you've also accomplished something else that's extremely important, which I will get to in a moment because I just realized I inserted something about DevOps. Those of you who have initiated a DevOps culture in your company know that the DevOps team is responsible for creating and deploying software updates constantly and as quickly as possible. And there are companies that are now updating their software 200 or 300 times a day. So they have to be moving very quickly. And therefore, they can't afford delay of any kind. Now, there are many things that can delay the DevOps team. And if the ops side of the DevOps team is delayed, well, you bet that's going to delay the dev side of the DevOps team. So we have to be able to get in front of operational obstacles, things that might occur that would slow us down in deploying the next iteration. We have to be really forward thinking in identifying anomalies that might make it more difficult to load these new iterations of software and get them up and running. And all of that, not only is it there to make the users operate more productively, but also to optimize our spending on IT. Yeah, faster, better should also equal less expensive. Ultimately, by leveraging AI and ML, we create less noise in the environment. There's less to have to pay attention to. There are fewer alerts. You know, there's more smooth operation. And because we're getting better responses from our telemetry, we achieve more clarity for the operations people. So they know exactly what's going on the network when they go to deploy the next iteration. They also achieve a greater depth of vision. You know, most great operators, most great network engineers can take the data and visualize from it and determine what are the things we should do to improve the network overall. What have we not yet done? And hopefully this surfaces issues that do require that deeper level of improvement that they can add. So now we finally get to that last point I wanted to make. Sum it up. When we use AIOps to help us with the visibility imperative, we can see all the incoming traffic. We can see all the outgoing traffic too. We can analyze it instantly, which helps us determine causes in real time, creates solutions in real time so we can resolve problems immediately. If you walk away with nothing else today, just remember that concept. AI ops takes you from visibility to resolution very, very quickly. And that provides the all-important feature of enhancing your user's experience. Because ultimately, that's what we're all here for. We're here to make it work better for our users so they can get their jobs done faster, more efficiently, so that products can be turned out faster and efficiently, and therefore corporate profits increase. With that, I'm going to turn it back to John to see if we have any questions.
We do. We have quite a few here. Let me remind everyone that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's start with this question from Lynn James. Hi, Lynn. Welcome. Lynn is a frequent flyer.
Frequent flyer.
And the question here is, can you, and always good questions as well. Can you explain how AIOps leverages AI and machine learning to analyze and interpret network data for better insights?
Oh, yeah. The problem with Lynn's questions is they're always way too deep, and I don't have the hours it takes to explain all that. I will say, however, that our next presenter, JD, is going to take you through some of the technologies and may offer you deeper insight into how it's done. To explain AI would take, to explain AI applied to network operations. Lynn, I would love to be able to go through all that, but I think JD is going to be more qualified and hopefully can give you more.
Okay, we've got a good question here from Jennifer, who asks, does faster, better always pay off in the end? Couldn't that be a recipe for rework?
Ooh, that's a great question. Well, if it were people working faster and better, sure, people make mistakes. You could say that moving faster increases the likelihood of mistakes when you're talking about a human, but really, when you're talking about digital devices, it's not the same thing. Digital devices do the same thing the same way every time. They're as reliable as can be, unless something breaks, in which case everything comes to a halt. But that's not what we're talking about. So using automation to get things done faster and better means that people are freed up from those things and can do things that take more concentration and take more time. And so they can enjoy a better quality of work that's more rewarding to them. Hope that's responsive to what you meant.
Okay, here's one from Zeke, who's wondering, Howard, is AIOps based on ChatGPT?
It depends on whose AIOps you're talking about. ChatGPT is one implementation of an engine that uses large language models. There are many. ChatGPT has done a better job of getting their name out there. But again, I suspect, I'm not sure, but I think JD will probably talk about that in the course of the Juniper presentation. At least I hope so. I'd like to learn more about it.
Okay, here's one from Annie, who's wondering, Howard, what market segment do you think AIOps is most appropriate for?
We've got a salesperson in the mix. Okay. That's a great question. I think logically, you'd instinctively think that the automation would pay off most in a larger network. And a larger network is probably operated by a larger company. So I think it's easy to say that, Fortune-sized companies, mid-range sized companies that are, really substantial and have plenty of need for IT, have plenty of need for AI ops to make that IT more efficient. But that doesn't, I just want to point out that doesn't cut out the smaller businesses. There are smaller businesses that are basing themselves on technology. that are leveraging technology to make it possible to do what they do. And if it's that critical component of their business, yeah, I would think they'd want AIOps too. So yeah, bigger, 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 maybe smaller.
Okay, we've got time for one more here. This is the question is, Howard, will AIOps eventually replace human network operators completely? The fear and the pit of all of our stomachs.
In front of all these people, I'm going to say no, because otherwise they might come and hurt me. Will it completely? Well, it's true. You know, I can give you two answers to that. One answer is that I still believe that networking, I mean, one of the things that attracted me to technology and to digital devices and to networking in the first place is the fact that imagination counts. You can use your imagination to create new things and to expand upon things. And so I don't see a day yet where AI will feature imagination. That is not to say that it never will. I mean, Bill Gates, Elon Musk have actually agreed with each other that where we are today is nothing to worry about because AI can perform useful, positive functions, but it's only of moderate intelligence. There will come a day when they achieve super intelligence, and that's when we need to worry. So at that point, I guess all bets are off. I don't know what will happen. But then again, two of the most brilliant men in the world don't either. So good company.
Fascinating. Well, as one of those with moderate intelligence, but hopefully performing a useful function,